In this example, we want to find equations of the tangents to the curve x equals 6t squared plus 2 and y equals 4t cubed plus 2 that pass through the point 8, 6. So I'm going to start off by finding dx dt, or the derivative of x with respect to t. That's going to be 12t. And then similarly, let's find dy dt. That's equal to 12t squared. And ultimately, we want to find dy dx, which is given by dy dt over dx dt. So that's equal to 12t squared over 12t. And if you simplify that, that ends up equaling t. So ultimately, we get that dy dx is equal to t. So now what we want to do is we want to find tangent lines that have a slope of t and pass through the point 8, 6. So before I proceed, let's look at what's happening from a graphical standpoint in Desmos. All right, so I'm on Desmos, our online graphing calculator, and I've gone ahead and I've plotted my parametric curve. I have x is equal to 6t squared plus 2, and y is equal to 4t cubed plus 2, and I'm just having t, our parameter, range between -10 and +10. So here, what we want is we want to find any tangent line to the curve that's going to pass through the ordered pair 8, 6. So let's just highlight 8, 6 on our graph really quickly. So there's 8, 6, and we want to find any tangent line that goes to that point. So I'm going to go ahead and unhighlight this, and that will show me a line. And I'm going to have m kind of vary, where m is our slope. And so we're trying to find places where we have a tangent line to the curve that goes through this point. And so I can see kind of one place where it would be a tangent line, and it's kind of here as we get to a slope of 1. So this we can see as a tangent line to the curve. And then another place that happens to be here as I get closer and closer. And it looks like the other place is happening when our slope of our tangent line is equal to -2. So let's go ahead and go back and do some algebra here. So given our parametric equations, I know that the equation of a tangent line that goes to the point 8, 6 is going to look like, y minus 6 is equal to t, and I'm plugging in t for our slope since that's what we found the derivative with respect to x to be. And then we have x minus 8. Now, our goal here is to figure out what t is. And so one way that we could do that is I know that x is equal to 6t squared plus 2 and y is equal to 4t cubed plus 2. And what I can do is I can take those and plug them in to these locations in our equation. So I'm going to go ahead and replace y. And then I'm going to go ahead and replace x. And if I simplify this, I get 4t cubed minus 4 is equal to 6t cubed minus 6t. And then I can subtract 4t cubed from both sides. And I can also add 4 to both sides. So we're going to end up getting the equation 2t cubed minus 6t plus 4 is equal to 0. And from Desmos, we kind of saw that our solutions to this should be 1 and -2. But let's just check to see that that works. So if I plugged in 1, we would get 2 minus 6 plus 4, which does end up equaling 0. So that's a solution to this equation. And then let's try -2. I guess I shouldn't have put this equals 0 here, because we're checking to see if that's true. So -2 cubed is -8, and then times 2 is -16, plus 12 plus 4. That's going to end up equaling 0 as well. So that means that in our equation here, for t, we can replace that with 1 and -2, and those are going to give us the equations of the tangent lines that we're looking for. So let's go ahead and do that. So for one of the tangent lines, we get y minus 6 is equal to 1 times x minus 8. If I wanted to put that in slope-intercept form, let's see, I'd have x minus 8 plus 6, and that's going to be y equals x minus 2. So there's one of our solutions. Let's go ahead and plug in -2 for t. If we did that, we'd get y minus 6 is equal to -2 times x minus 8. If I distribute the -2, we get that, and then I can add 6 to both sides, and we get y equals -2x plus 22. And there's the equation of our other tangent line. That concludes this example.